Hello everyone, we're now starting the class. Earlier, we introduced the nameplate data of transformers, the no-load operation of transformers, as well as the load operation of transformers. When analyzing transformers, we use basic equations, equivalent circuits, or Phasor diagrams. In these methods, it is necessary to know the parameters of the transformer. The parameters of the transformer are not marked on the nameplate and product catalog. They can be determined by experimental methods. So starting today, we will introduce the experimental methods to obtain transformer parameters and the relevant data to facilitate the selection and analysis of transformers. Equivalent circuits are effective tools for analyzing and calculating transformers. The various resistance, reactances, or impedances, such as RK, XK, RM, XM, etc., are called transformer parameters. They directly affect the operating capacity of the transformer. For manufactured transformers, these parameters can be measured by experimental methods. First, let's look at the no-load test of transformers. This test can help us obtain which parameters. The answer is the no-load test can measure the excitation parameters of the transformer. Let's see the purpose of this test. By measuring the no-load current I0 and primary and secondary voltages and no-load power P0 to determine the transformer's transformation ratio K, percentage of no-load current, iron loss, P ferrom, and excitation impedance. Next, let's look at the no-load test wiring diagram of the transformer. This is a single-phase transformer wiring diagram. The diagram shows 4 instruments, which are a power meter, an ammeter, and 2 voltmeters. The 2 voltmeters are connected in parallel in the circuit. One measures the input voltage on the power supply side. The other measures the no-load voltage U20 on the load side. The ammeter is connected in series in the circuit. The power meter is denoted by W. Unlike the ammeter and voltmeter, the power meter has 4 terminals. Pay attention to the labels on the same terminals when wiring. Next to it is the equivalent circuit diagram. Next, we will discuss the requirements and analysis, that is, the precautions. First, for safety and ease of obtaining low voltage power, it is usually considered to apply voltage to the low voltage side, open the high voltage side, and perform a no-load test. Second, the meaning of each instrument reading. There are 2 voltmeters. One measures the rated voltage U1N on the load voltage side. One measures the open circuit voltage U20 on the high voltage side. U20 is also its rated voltage. As we mentioned earlier, when discussing nameplate data, the power meter measures the no-load loss P0, which is approximately the iron loss. During no-load operation, the power factor cosine phi is approximately 0.2. Therefore, the power meter used in the test should be a low power factor meter. Otherwise, there will be a significant measurement errors. The ammeter measures the no-load current I0. Third, the applied voltage starts slightly above the rated voltage and is adjusted in one direction within a certain range. When the voltage is adjusted from high to low, measure U1, U20, I0, P0, and plot the corresponding curves during the voltage change process. Fourth, Zm RAM, XIM, because the excitation parameters ZM, RM, XM are related to the saturation level of the core magnetic circuit, and transformers usually operate at rated voltage. Therefore, the no-load test data should correspond to the data when U1 equals to U1N to ensure that the saturation level of the magnetic circuit corresponds to UN. Fifth, neglect R1 and X1. That is, P0 is approximately equal to P ferrum. No-load loss P0 is approximately the ion loss. Sixth, determine the no-load parameters. Transformation ratio of the transformer. Percentage of no-load current. Calculation of excitation parameters. After obtaining the parameters, the equivalent circuit diagram can be drawn. Seventh, because the no-load test is conducted on the low voltage side, the measured excitation parameters are the values converted to the low voltage side. If conversion to the high voltage side is required, the above parameters should be multiplied by the square of the transformation ratio K. Eighth, to facilitate adjustment of the applied voltage, a voltage regulator is generally used. The no-load test must use an external rated voltage. Apply the rated voltage to the primary and secondary sides separately. The no-load losses measured should be equal. Here is a three-phase no-load test wiring diagram. For three-phase transformers, the voltages, currents, and power in each formula are phase values, but the measured data are line voltage, line current, and three-phase total power. For three-phase transformers, the measured power is three-phase, while the excitation parameters refer to each phase. Therefore, in the calculation, the three-phase power should be divided by 3. That is, the power of one phase should be used for the calculation. At the same time, the measured line value data should be converted into phase value data. In this class, we determined the transformer's no-load current I0, transformation ratio K, no-load loss P0, and excitation parameters ZM, RM, XM. In the next class, we will discuss the short circuit test. Alright, that's all for today's lesson. Thank you all for watching.